function parameter, it can be used to provide implicit type conversion. The explicit function modifier prevents this behavior. Let's take a look at how this works. Make a copy of implicit.explicit.cpp and paste it into our working project and open it up in our editor. I'm going to maximize this so that we can see it. And I'll just scroll through here briefly for those who are typing along at home. So this is a partial class. This is hypothetically the beginning of a roll your own string class. And it's getting a string length parameter. And really that's all that the class does at this point. It just has the one data member, this size data member, and it's of type size t, and it's going to be eventually used as some kind of a string thing. And so we have two constructors. We have a constructor from a size t, which gets automatically converted from int, and we have a constructor from a C string, which will take the size from the C string. And then we have this little getter, this little accessor in line 11 that'll return the size so that we can see what's going on. So it's really just for experimental purposes. So the first constructor is implemented beginning on line 14. And you see it says it takes a size t variable and it checks to make sure that it's not greater than max len, and it assigns it to size. And then you can see the constructor beginning on line 19 takes a string and it finds the length of that string and it uses that for size. And then we have our little getter on line 30. And then starting on line 34, we have our little test bed. So there's two things in here. In the main function, we construct an object using s equals, and I assign a character by mistake. It was supposed to be a string of one length, but I assigned a character, so that's going to get converted into the size t, and it'll take the value of that. And then you see the other implicit conversion that happens is in the function call. You notice that the function is declared as requiring a BW size object, and instead I'm just passing it this character. Again, by mistake, it was supposed to be a string, but it's a character. And that's getting automatically converted also into this unsigned integer that is size t. And so we have these implicit conversions going along, and in both cases, they're really something that we didn't intend, but they're happening by accident. And you'll notice that when I compile and run this, that it actually works. It doesn't do what I intended. Instead of giving me that one length that I might have meant, this character is getting converted to the integer value 120, and it's getting assigned to size. So we can make this not happen by using the explicit keyword. So both of these syntaxes are actually designed to do implicit conversions. When you initialize an object with the equals sign instead of the parentheses, it's designed to do an implicit conversion. And when you initialize an object by passing something into a function like this, it's also doing an implicit conversion because the function is requesting a BW size object and I'm actually giving it something else. And so it tries to do a conversion. So we can prevent these implicit conversions by using the explicit keyword. So if I just type explicit here and here, now none of this will work anymore and we won't actually even be able to compile. If I try to compile this, I get errors, and the errors look like this. Conversion from char to non-scalar type BW size requested, invalid initialization of reference const from expression type char. So we're having problems here. There's our conversion problem. There's this weird initialization of type from char that's also a conversion problem. And here we have passing argument 1, that problem there. So this no longer works because we have explicit. Once we have explicit, we have to actually match things. In fact, let's comment out the second one and just start with the first one. So I'll comment that out. And then this one here, let's just try to give it a number, 125. And if I save that and try to compile it, we still have an error because it's still trying to do an implicit conversion for two reasons. One is that I'm using this syntax with the equal sign, and the other is that that's an int. It's not a size t. So I can make this a size t. And we'll try that, save that, and compile it. And I get the little, you can just hit run in background if you get this. And you see we still have an error because it's still trying to do an implicit conversion. Because this syntax here is actually the syntax of the copy constructor. And that's not the kind of a constructor we have. We have the parameterized constructor. So I need to actually even do this in order for this to work. So now I save this and run it, and now it works. Because I'm calling the constructor that I intended and I'm calling it with the type that I intended. That's a little bit inconvenient to have it be a size t. If I want this to be an int, I can come up here and instead of the size t, I can say const unsigned int. And I'll come down here into the implementation and do the same thing, const unsigned int. And now I should be able to initialize it like that. And there we have it. Now with func, let's try to get it to use this other constructor here. Obviously, if I just uncomment this and put in a string instead of that character, we're not going to expect that to run. Why? Because we're still trying to do an implicit conversion. This function is requesting a BW size object, and I'm passing it a string. And so if I compile this, I get errors, and the error looks something like this. Invalid arguments, invalid initialization of reference type, and here we have a passing argument. So it really needs for me to pass it a BW size object, so I need to do it like this. And what this will do is this will construct a temporary object and pass it. So this constructs a temporary object of BW size type, and it initializes it with that constant character string. And so if I compile this and run it, we get a size of 1, which is exactly right. And so if I give this 5 of them and compile and run that, we'll get a size of 5. So here we see that by using the explicit keyword, we have prevented implicit conversions in our constructors. Now let's delete